Hello, algebra students. Mr. Lawrence here, and Aaron Gabriel asked me if I'd make a video about no solution in all real numbers. So Aaron, I'll try to cover this as thoroughly as possible, even going back to some things that you probably already understand, but hopefully going over those things will help you comprehend the things that you aren't quite getting yet, okay? So no solution is going to happen. What it literally means is that there is no number on the number line that makes the equation or the inequality true. I mean, that's what we're after. We're after truth. For example, if I say that x plus 1 equals 5, well, we could subtract 1 from each side, and then we get x equals 4. Now let me ask you this. Is it true that 4 plus 1 equals 5? Of course it is. Is it true for any other number that if I add 1 to it, I will get 5? No, it's not. If it's 6, I'm going to get 7. If the first number was -4, I'd get -3. Right? There's no other solution. So on the entire number line, the only solution possible is x equals 4. When I get a no solution problem, it means there are no numbers on the number line that can make this statement true. Okay, check out this one here, the 2x plus 5 equals 2x plus 7. Now some of you right off the bat can say, hey, I know there's no solution here. But if you can't, remember I taught you that when there are variables on both sides, I take care of that first. I get rid of the variables, right? Okay, and so now I'm going to have 5 equals 7. That should bug the snot out of you. That's such a lie. There's no truth there. 5 does not equal 7. And since I got a statement that is always a lie, there is no number on the number line that I can multiply by 2 and add 5 to it, and multiply by 2 and add 7, and I'll get the same answer. I won't. If you pick like 1,000, you're going to get 2,005. But over here, you're going to get 2,007. If I pick -5, let's see, I'm going to get -10 plus 5 will be -5. Here I'm going to get -10 plus 7, I'm going to get -3. There's no number anywhere on the number line that can make this equation true. And I know that because when I solved it, I got a statement that was never true. So there's no solution here. Okay, let's look at this inequality. All right, again, I've taught you to get rid of the variables on both sides first. Make it so there's only variables on one side if possible. And so I'm going to subtract 6x from both sides. And then I'm going to get -5 is greater than 2. Well, that's not true. That's a lie. This problem has no solution. There is no solution to this problem because, sorry, I guess I don't know how to spell solution. There's no solution to this problem because -5 is never greater than 2. No, and you can't say, well, if I add 10 to it. No, because you'd have to add 10 to both sides of the inequality. And so you'd still get a statement that's a lie. That's false. Okay, how about this one? We've got 3x minus 1 equals 3x minus 1. Now, again, some of you can tell right away what's going to happen. But in case you can't, let's get rid of the variables on both sides. Let's subtract 3x and subtract 3x. And I'm going to get -1 equals -1. Hey, I like that. That's always true, isn't it? Yeah, there is never a time when -1 does not equal -1. This means that the solution is any real number. All real numbers will work. You can pick any number on the number line, put it in for x, and you will get a true statement. Yeah, okay? All right, now, the question came up because of absolute value inequalities. Sometimes students can't tell those as easily. So let's, before we do one of those, let's do this absolute value inequality here. Let's go with 2x plus 3, and we're going to make that less than or equal to, let's go with 9. Okay, do me a favor, pause the video and solve that, including making the number line, okay? Okay, here comes the solution, right? We're going to get 2x plus 3 is less than or equal to 9. This is an and. We're going to get 2x plus 3 is greater than or equal to -9, right? All right, so now I'm going to subtract 3 from both sides. and I'm going to get 2x less than or equal to 6, dividing by 2, and I'm going to get x is less than or equal to 3, right? Okay, and there's going to be another part to it. So I got to subtract 3 here, and then I'm going to get 2x is greater than or equal to negative 12. Divide by 2, I'm going to get x. The inequality will not flip because I didn't divide by a negative. Dividing into a negative doesn't cause the change. Oops, and I just flipped it. Silly Mr. Lawrence. Good thing I caught that right away. All right, so we're going to make that greater than or equal to negative 6. Now to get my picture on a number line, okay, it's an and, so I'm going to have, excuse me, negative 6, I'm going to have 3. They're going to be closed points, right? Because they are solutions. And the shading will be in between. Now, what does the shading mean? Well, the shading is showing me all possible solutions to the original inequality. I think the original inequality was what? The absolute value of 2x plus 3 is less than or equal to 9. If I pick any number in here, 0, 1, 1.45923876541, 1/2, negative 3/4, negative 5 1/4, any number in this range, and I substitute it in for x into the original inequality, I'll get a true statement. The number line that's not shaded, you know, everything greater than 3, everything less than negative 6, any number in that region will not give me a true statement, will give me a false statement. So the other day in class I was saying, well, ands usually look like false, true, and then false again. They have a false section, a true section of the graph, and then another false section, okay? And I had mentioned that ORs, since ORs go out like this, are going to be the opposite. Here you're going to have a true, a false, and a true, right? Okay, so hold on, I got a sneeze coming on, so watch your volume so your ears don't get blown out. Sorry about that. Okay, so any number I pick in here is going to give me a true statement. Any number I pick here or here will give me a false statement. So let's go back to these absolute value inequalities. Go ahead and solve the first one on your own, okay? Hopefully you've solved it. If you haven't, pause the video and solve it. Let's see, equals are done as or, so I'm going to get x equals negative 2 or x equals 2. Okay, now there's not really any shading for this one, but I can do it like this. I think the two solutions for this one are at negative 2 and at positive 2. So I'm going to put a point here and a point here. All right, and now I'm going to check my work. I'm going to put 2. See, I think the solutions are 2 and negative 2. So if I put them into the absolute value inequality, they should produce a true answer or a true statement. So I'm going to put 2 in. So I've got the absolute value of 2, which of course is equal to 2, but that does not equal negative 2. See, it's supposed to equal negative 2. It doesn't equal negative 2, which means that this one doesn't work. It's not a true statement. Okay. Negative 2, same thing. If I put a negative 2 in there, I get the absolute value of negative 2, which is positive 2. That doesn't, so nothing works. This problem has no solution. Now, I could have told you it was no solution without doing all this work, because I know the definition of absolute value. Absolute value is the distance from 0 on a number line. And we know that distances are always greater than or equal to 0. Since it's asking me for a distance that's equal to a negative number, that's not possible. So there can't be any solution. But if you don't get that, you can do the work and then test. Okay, very intelligent way to do it. All right, go ahead and try this one. Please do it before I show you mine. Here comes mine if you haven't seen it, or excuse me, haven't done it. Pause the video and go ahead and solve it and then play. Okay, so I'm going to break it up into two inequalities, pretending like I don't know what's going to happen. So x plus 2 is going to be greater than -4. This is an OR, right? And remember that with an OR, only one half of it has to be true at any given time. So I'm going to get that x is greater than -6, right? I'm going to subtract 2 from each side. So if I have a number line, I'm going to have -6, and I'm going to shade everything greater than -6, right? But I still have a second half to the problem, and so I'm going to subtract 2 from both sides. I'm going to get x is going to be less than 2. Well, that means that 2, I'm going to have an open point, and I'm going to shade everything less than 2. What ended up getting shaded? The entire number line. Yeah, even the -6 and the 2, because while -6 doesn't make this part true, it certainly makes that part true. And remember, this is an OR, therefore only one of these has to be true at any given time. So no matter what number you pick on the number line, any number you pick, it will make at least one of these inequalities true. Okay, if I pick 2, 2 is not less than 2, but 2 is greater than -6. So 2 is in my solution set. If I pick 1,000,000, well, that's true on this side, right? If I pick -35, well, that's true over here. If you want to test them, you can plug numbers in here. Pick a number less than -6, between -6 and 2, and greater than 2, and you will still get a true statement. Now, even if you pick these open points, if I put -6 plus 2 is -4, absolute value of -4 is 4. 4 is greater than -4. There you go. There's the whole thing. Whole thing. All right, go ahead and try this one. Here comes my solution. And I'm just going to cut to the chase. This one has no solution. Do you know how I know? Because the absolute value is less than a negative. Distances are always 0 or greater. I can't have a distance less than 0. This one is telling me that the distance is less than -1. If you go through and do it, you're going to find that you're going to get 3 regions, and they're not going to be true. No part of them will be true. All right, now, last thing I want to say, if you have something more complicated like this, you might not want to determine if it's no solution or all real numbers right away. I would eliminate the 5 and then eliminate the 2 and then see where I'm at. So, in fact, let's make that a -5. So if I add 5 to both sides, I end up with 2 times the absolute value of 3x plus 1, which is greater than 3. And then I divide by 2, get the absolute value of 3x plus 1 is greater than 1.5. Well, that doesn't bother me, you see. Whereas here, this -2 was bothering me, but once I did some algebra, it wasn't really a negative over there. So isolate the absolute value before you make your determination if you're going to use one of those shortcuts. Okay, I hope that helps you. If not, check out Khan Academy. Get on there, absolute values having no solution, and see how they explain it. Maybe you'll like that way better. The goal is for you to understand what you're doing. It doesn't matter how you get there. All right, that's it for the video. Mr. Lawrence signing off. Have a good night, everybody.